Today we're going to learn about completing the square. Specifically, what does it mean to complete the square? For example, if we're given the expression x squared plus 6x and asked to complete the square, well, what does that mean and how do we do it? Okay, let's first think of x squared and 6x as rectangular areas. Okay, like this. We're going to take the x squared and represent it with a square. The sides of it are x. So the area of this square is x squared. Okay? Now let's take a look at the 6x, and we're going to use 6 little rectangles, each of them with one side x and the other side equal to 1. And together they add up to be 6x. And the reason I'm using 6 little ones is because instead of one large one with one side be 6 is because I know I need to split it up like this. Okay, I'm going to split the 6x up into 3 on this side and 3 on this side, and the idea is that I'm going to keep the sides of my figure the same size because I'm talking about making a square. Okay, now the question is, what do I have to do in here to complete this big square? Okay, this column has a width of 1, this column has a width of 1, these rows all have a width of 1. Okay, so that would give me 9 little squares that each have sides of 1. Okay, this area is 1, this area is 1, I get an area of 9. Okay, now let's do this with algebra. Okay, we're given x squared plus 6x, we're asked to complete the square, we're going to split our 6x up into 2 parts, and we're going to then take a look here. The coefficient of the x term, not the x squared term, but the x term is 6. We're going to divide that in by 2, like this, okay? Just exactly what we did up here. I have 3 here and 3 here. Well, 3 is 6 divided by 2. Okay, it's also not an accident that 6 divided by 2 equals 3, and that 3 squared equals 9, and 9 is the number of little squares that I need. Okay, so if I add 9 to x squared plus 6x, I'm going to complete the square. Now I'm going to write my 9, I can write my 9 as 6 divided by 2 quantity squared, because that's going to help me later on when I use this to solve equations. Okay, all right, now we can see that this is a square in the figure. This side has the exact same size as this side, so the entire figure is a square. How is it a square algebraically? Well, let's write the dimensions of the square up here. This is x. I have 3 little ones here. This is x plus 3. This one is x plus 3. And if I want the area of the full figure here, it's going to be x plus 3 times x plus 3. Or x plus 3 squared. Okay. Well, it turns out that if I factor x squared plus 6x plus 9, it factors to x plus 3 times x plus 3, which can also be written as x plus 3 quantity squared. It is not an accident that we refer to powers of 2 as the square of something, because anything that's been taken to a power of 2 can be represented by a square.